For over 150 years, mathematicians have asked, do smooth solutions to the 3D Navier-Stokes equation stay smooth forever, or can they blow up in finite time? It seems that the answer is hiding in knot theory. Recently, I posted a video showing how primes map elegantly to a torus. Notice that as the prime numbers increase, patterns form on the torus. I realize that this may show why Navier-Stokes equations don't blow up, and the CRT torus reveals why. The torus is a natural space for Fourier modes. Each point represents a wave vector k positioned by k mod p around one circle and k mod p around the other. This is the Chinese remainder theorem, CRT. Every integer maps uniquely to a point on the p times q torus. For incompressible fluids, this isn't just math, it's geometry. Watch the green threading paths. They show how incompressible flow must travel. There are no shortcuts. The condition u equals 0 isn't just algebra, it's a topological cage that locks energy into specific cycles. The white dots mark the CRT lattice points where triads close. K1 plus K2 plus K3 congruent to 0 mod m. See how the threading wraps 2 times one way and 3 times the other. This is a trefoil knot, the simplest knot in mathematics. Once energy threads into this pattern, it's topologically trapped. A singularity would require this knot to be untangled and for it to untangle itself, but knots don't untie themselves ever. A more complex torus knot, but the same principle holds. Each path is topologically locked. Blowups would require creating infinitely many distinct knot types in finite time. Knot theory forbids it. Let me show you why this matters for physics. In fluid dynamics, we track something called helicity, a measure of how linked and twisted the flow is. Watch how these green paths never cross themselves. They're linked but distinct. The linking is exactly what helicity measures. And here's the key. Helicity is approximately conserved even with viscosity. Now, if we add viscosity, the fluid's natural friction, in the full mathematical proof, this creates exponential decay of what we call the threading deficit. The animation doesn't capture this perfectly, but the math is clear. Viscosity always wins against nonlinear concentration. The higher the frequency, the faster it dies. Here's the stunning realization. Finite time blowups would require creating an infinitely complex knot in finite time. But knot complexity is a topological invariant. It can only grow exponentially at best. Blowups need infinite complexity at finite time. Impossible contradiction QED. The knot can twist, braid, and writhe, but it cannot unknot, and it cannot spawn infinite complexity in finite time. Therefore, no blowup. The Clay Millennium problem for Navier-Stokes regularity reduces to a theorem in knot topology.